Now, question number 19 involves the logic of polygons as well as the logic of number systems. So, in number systems, you have done a concept in which we calculate the number of factors. So, the same logic will be applied here. Now, here we have to find out the number of regular polygons that will exist such that all the interior angles are integers. Now here the length of each side is given, but this information is actually not relevant. So whatever be the length, it does not matter at all. Okay. So first of all, what will be the measure of each interior angle in a regular polygon? Let's write it down. So sum of all the interior angles is 180 into n minus 2, and measure of each interior angle will be 180 into n minus 2 divided by n. So this is the measure of each interior angle in a regular polygon. I can write it as 180n minus 360 whole divided by n, which can further be written as 180 minus 360 divided by n. Now, this entire value will be an integer. This entire value will be an integer if this second term here will be an integer. That means 360 upon n will be an integer, and 360 upon n will be an integer if 360 is completely divisible by n. Okay, so that means n will be the factor of 360. So let us try to find out the number of possible values of n. Okay, so number of possible values of n will be all the factors of 360. So let's write 360 as the product of prime factors first of all. So it will be 2 cube multiplied by 3 raised to the power 2 multiplied by 5 raised to the power 1. So the number of factors of this number 360 will be 4 into 3 into 2, that is 24. Okay, so 24, there will be 24 values of n that will completely divide 360. Now, what is n? N is the number of sides. Okay, so if I'll write all the values of n starting from the smallest value, the factors of 360 will be either 1, 2, 3, 4, 5, 6, then it will be 8 and so on, right? Now, in a polygon, a closed figure can be made if the number of sides is greater than or equal to 3. Okay, so 1 and 2 were among the factors of 360, but they cannot be the number of sides of a regular polygon. All right, so I'll remove these two values out of 24 values of n. Okay, and that will give me the answer for this question. So out of 24 values of n that I've calculated, 1 and 2, these cannot be the values of n. These cannot be the number of sides of a regular polygon. So I'll subtract 2. So the number will be 22. So there can be 22 regular polygons that can exist such that all the interior angles are integers. So correct answer will be option B, that is 22.